Today's question is total decoding messages from Geeks for Geeks, and it's a medium level question. So it says that we'll have 1 till 26, which is going to represent all the alphabet characters from A to Z, and we're supposed to find the ways in which we can decode a message. So we'll be given a string, and we are going to find the number of ways in which we can decode this given string. So this string is eventually representing the digits from 1 till 26, and we are supposed to find all the ways in which we can form different combination of the alphabets. For an instance, here in example number 1, we have been given 1, 2 and 3. So what we have done is we have taken every digit individually. So it's ideally an alphabet, character, because we are given an input which is of a string type. So 1 will be character 1, 2 will be character 2, and 3 will be character 3. But just for the simplicity, I will be saying that these are digits. So 1 is going to represent A, 2 is going to represent B, and 3 is going to represent C when I take all of them individually. But then I also know that I can have at most at the digit, I can have at most the number which is the combination of two digits if it is in between 1 till 26. So I am going to combine 12 together and 1 and 2 together, forming 12, which is going to represent L, and 3 will be aside a single, like it will be decoded individually, which is going to represent C. Similarly, I can also see that 2 and 3 can be combined with each other, and 2 and 3 will form W, and 1 is going to represent A. So all in these ways we can decode this particular message 1, 2, 3. That is the most we can find it out. So it either the sender is going to send ABC to the receiver, or he meant LC, or he meant AW. The another example is giving us a bit more closer about the problem statement, which is 27. Now here we can obviously take 2 and 7 individually, which is giving us B and G, but 27 cannot be combined with each other. So there is no character or alphabet, there is no alphabet which can be replaced by 27 because it is outside the range. The range is from 1 to 26. So I'm going to take this example, and we'll see how we can solve this problem. So here is a small recursion tree. So the first line here is range is 1 to 26. So we understood from here that all the alphabet, 1 is going to represent by A and 26 is representing Z. So everything will fall under this. Whatever is coming within this range is what we can replace it. Anything outside 26 or outside Z1, in fact, if it is 0, we cannot decode it because 0 is representing nothing in the English alphabet. So we need to just understand this range part first. And then what we can see is this the same example which we discussed, 1, 2 and 3. So how we are going to say that what all are the number of ways, or what are the number of ways in which we can decode this 1 to 3. So what we are going to do, we are going to take element by element. So we'll take 1 for the first time. When we say that, okay, I'm going to replace 1, so there is only two possibilities, right? Either take this 1 individually, or okay, I'm sorry, either take this individually or take these two in a pair. So that's the most we can do. So I'm taking this as an individual a candidate, and I'm going to replace this with by A, and I'm going to take 12 as a pair, and I'm going to replace this by L. So when I say that I have only, I'm just going to replace 1 by A, I am left with 2 and 3. So then 2 and 3 will again recursively do the same job as the same what we have done previously. And when I say that I have 12, I am left with only 3. And 3, just it will, as we know that any single digit is going to basically I mean, like, decode it in only one single way, because if it is 1, then it is A, nothing else. If it is 2, then it is B and nothing else. So if it is 3, then it is C and nothing else. So it is going to return 1 to the parent. So this is going to return 1, because now here we started backtracking because we don't have anything else. So now we are returning back to the parent, and we are returning with the value 1. We need to discuss this part because it is going to grow further. So when we had 2 and 3, we are again going to do the same thing. So I took 2 individually, and I'm going to replace that with B, and I'm left with 3. and 3, as we have seen previously, that it is going to return 1. In this case also it is going to return 1. So another thing which you must have noticed, that first it is a recursion problem, second we can see the sub problems are repeating. See that 3 is getting repeated in two different branches. We know already the value of 3, so it is always a wise option to take the value of previously calculated 3 and replace it in this situation rather than recalculating it. So that is what the DP is basically. So we now fairly know that it is a recursive problem, but then we can see the sub problems getting repeated, so we'll introduce DP. Fair enough. Now we can see that uh, there was this we were discussing about this branch. Now let's see in this branch. So as we were discussing, either we will take individually or we'll combine. So we took individually 2, now we are combining 2 with 3, and 2 with 3 is 23, which is within the range. So we are going to take 23. Now we have completed everything. Now we don't have anything in this branch, so we stopped. But when we stopped, we have actually calculated 2 and 3, right, successfully. So it is also going to return us 1. So 3 is also returning 1, and 23 is also returning 1 after stopping, like after getting stopped, I mean like after completing the entire branch. So 23 is going to have value, let me change the color. 23 is going to have value 1 plus 1, which is 2. We can verify this. So when we have 23, we have one way. One way is take each digit individually, 2 and 3, which is B and C. And then there is another way in which we can combine, where we can combine this 2 and 3, and we can form W, right? So here it is B and C. So this is B. So what we are discussing here, that we are discussing about the various possible ways in which we can find or we can decode this particular message. So this part of this branch is representing when we are taking things individually. We took 2 and we are left with 3, and here we combine 2 and 3. So we are done. Here with 23, we saw that okay, there are only two possible ways in which we can decode 23. 3 was returning already 1. Now when we come to the parent, then what do we have? This guy is returning 2 and this guy is returning 1, which means 2 plus 1, 3. So the answer is 3 for 123, 1, 2, 3. This particular string given to us will be decoded in 3 possible ways. That is what we have discussed. 1, 2, 3 is going to get decoded in 3 possible ways, and these are the possible ways. So this is the way in which we can find it. When we are coding, we will be thinking in this direction, that we are breaking this given problem into different sub problems, taking individually and taking everything in pair. And if that pair is valid, then we are replacing that pair with the alphabet. And when we stop, if the stop is genuine, as in like if the stop when we stopped when I stopped at 23 and I see that 23 is a valid pair which is going to get in future replaced by W, then I'm going to return 1. Just imagine it was 27 by it was 27 for an instance, then we would have not returned anything from here, we would have returned 0. So since it was a valid pair, I'm returning 1 after completing this particular branch, and 3 was returning 1, and it's obvious because 3 will be representing C. That's all. So this was all about the recursion tree. Let me erase this and let me come back to I plus 1 and I plus 2. So what I plus 1 and I plus 2 is basically representing that what we can see when we are standing at 1, then we can see that either I can take 1 individually, and we are left with 2 and 3. So what are we left with from the position I plus 1? So whatever is in this side of the tree is I plus 1, and whatever is in this side of the tree is I plus 2. And it's obvious, it's just a small observation which we need to understand, that when I'm just taking an individual digit, then I am taking all the rest because I have to grow further. The recursion tree is going to grow further doing the same job. So what are the elements which I have to deal with in the future, which will be from I plus 1 till whatever length I have. And when I'm taking things in pair, then obviously I have stepped already to one step further, and I've included 1 and 2 together, and then I am left with 3. So it means that in this particular branch, whatever we are going to deal with will be from I plus 2. So this is representing I plus one element, whatever we have left with. For an instance, this is 0, this is 1, and this is 2, which means that when I was at 1, I'm going to take element from 0 plus 1, which is 1, so 2 and 3. And when I'm combining the elements 1 with 2, and I'm saying that I'm going to decode 1 and 2 together, then I have to step one step more further than the previous branch, which is 0 plus 2, which is nothing but 2. So these are the few observation which we can like conclude from this particular given recursion tree. Like one way was like, okay, we know that we have 1 2 3, and we know how many ways we can decode it, but when we are coding it, we have to understand that what technique we need to use to find all the way. So the recursion, I mean, like when we have divided this particular problem into sub problems, we can see that using recursion we can fairly very clearly we can say that we can solve this problem. But then once we saw that there is a repetition of these sub problems, we thought to introduce DP, because it's there is no point in doing the recalculation of 3 again and again. If we know that we have already dealt with this particular sub problem previously, then we are going to take that particular answer and then paste it here. So having said that, we can now jump into the coding part and see how to solve this. Since we have discussed this recursion tree in depth, it is just a piece of cake to solve this problem. So as it is a recursive problem, we are going to call our own function again and again. So I'm going to create a function uh, where the argument will be the string, and in sorry, it is going to take str and 0. All right. So, and that is what it is going to return. All right. Now, why I have to create this is because it should be of integer type. The name of the function is fun, and this is str, and this is int I. So what are we going to do here? Uh, as this function will be called multiple times, 1 2 3 call 2 3 2, I mean like 1 2 3 came up till 2 3, 2 3 will again do the same job as 1 2 3, and we came to 3. For an instance, it can, if this particular example was big enough, this might have got repeated here as well. So this is going to go until we are left with only one digit, or we are left with no digits. So that is what this is what we are going to do, and that fairly means that it is a recursive problem, and that is why we have created a separate function which is going to call itself multiple times until and unless the base condition hits and we are stopping. We stop there. And the another thing which talking about the argument string, obviously the whatever as an input we have been given, we are passing the same string, and this I is the starting position. So this is representing I actually. And now you will see how I am adding this I plus 1 and I plus 2 part later down in the code. So let's go back to the code. We'll say that if str of I is equals to 1, it's a character 1, then what are we going to do? If that is the case, then we'll certainly call this function again, and we have two options: str I plus 1, right? So there is, when my first element or str any of the element, right now since I is at 0, so we'll be dealing with the first element, but it's generalized statement. It says that at any point of time, if the element is 1, then obviously 1 can be replaced by a, right? So moving I plus 1 for the next iteration is good enough. So we'll do what? We'll call this function with I plus 1. We just move I plus 1, and we are now dealing with 2 and 3. So this came into picture now. Let me clear this up. So when, okay. So when I say that I have at any point of time, my given string has character 1, then we will know that if there is the length of this string is still there. So the base conditions I have not written, so that will take care of the length of this. If we are moving away, I mean, like if we have already completed the length of the string and all that. But right now we can just think in this direction, that if we have 1 at any place at any point, then we can simply move I plus 1 for the next iteration, and that is what I plus 1. I plus 1 is giving us the opportunity to deal with rest of the elements. All right, but it's not completed yet. There is another case in the same thing. So we know that in English, okay, let me just write this up. In alphabet, since we are representing from 1 till 26, we also know that we have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We have these, okay, we have these digits, right? And everything is starting with 1. So we know if 1 gets paired with any digit from 0 to 9, we can pair them and we can replace them with the corresponding alphabet, because from 10 till 20, 10 till 19, we have valid alphabets. And just considering this particular part, what we are going to do here is, when we say that when we pair up, so now we are pairing 1 with the next digit. When we are pairing it up, then we are moving I plus 2, because when I pair 1 with 2, I know that the rest element starts from I plus 2. So I'm going to say that we have fun, str, and I plus 2. And once this entire call gets completed, what we were able to see that while this 3 was returning 1, and this was also returning, this was also returning 1, and into at 23 location we were summing these results, right? So we'll sum this. So what we have said right now, we said that whenever at any point of time, if we found 1, then we can say that either we can take that individually, or we can also see that it can be paired. Why we can pair? Because the letter, or so the number from 10 till 19 has valid alphabet associated with it. And once both of the recursion gets completed, we are summing the result. That is what we have seen. We can extend this case more further. We can say or. We can do similar thing again. This was when the digit is 1 or starting with 1. But what will happen with stri if it is equals to 2? Because we have, don't forget, we have 20, 21, 22, 23, 24, 25, and 26. Now here the digits or the number is starting with 2, right? So if it is 2, then also we can move 1 step and 2 step, creating these branches. So if we have 2, then also we can take either 2 and 3 individually, or we can combine. But 1 was able to get combined from 0 till 9, so we did not didn't had to add anything after that. But for this 2, we have to add one extra check, which means, sorry, this is and it should be confirmed that I plus 1. When I say I am going to take 2 individually, then I don't have any problem. Individually means this particular thing will come into picture. But I am also allowing this particular case to move 2 step further, which means I'm trying to combine 2 with uh, the next element. So I am saying that that particular element which I am aiming to combine 2 with, it should be less than, sorry, greater than or equals to character 0 and str I plus 1 is greater than or equal to 6, because we only have to from 20 till 26. These are only the valid uh, digits which will be replaced by the alphabets. If it is 27, then we don't have anything. So when it comes to take the this particular function call, we need to be cautious for 2 specifically, because 2 can be combined with 7, 8, 9. So all those 3 numbers should not be there when I'm combining it. because this particular if is allowing us to create both the branches. One, if it is starting with 1 and if it is pairing with 1, we don't have to worry much. If it is 1, then we can blindly say that we can grow in both the direction. But if it is 2, then we can obviously grow in one direction without any doubt. But if while combining, we need to be just cautious that it should be within 26 strings. So that was this. Now here comes, all right, here comes one extra thing. What if this is not the case for 2? If what if 2 is paired with 7? In that case, okay, let me just add a return statement here. In that case, I'm going to return str I plus 1, because if it was 27 for an instance, if this was 27, then what would be the recursion tree? So we'll take 2 and we are left with 7. This is fair enough, this is good, and this is what I plus 1 is, right? So we have taken str and I plus 1. But when I'm combining 2 with 7 like this, and when I'm stopping here, then here it will return 0, because 27 is it can't be replaced by the alphabet. So this is going to return 0, and that is why we are not going to go in this branch whatsoever. So here we are going to stop, because we already know that the combination is not going to work. So we have just written I plus 1. Now let's talk about the base condition. It's a recursive function, so obviously base condition is very, very important. So we'll go with str dot size. What if the I, if it is greater or equals to, I mean, sorry, let me just replace it with I. If I is greater or equals to str dot size, if that is the case, then we have completed the entire string. This is, we are going to return 1, because we have completed the entire string. All right. Now there is another case, else if. There is another case which says that what if stri is 0? We have not discussed that yet in the example at least. If it is 0, then we are returning 0 in this situation. Why? Because the representation of the English alphabet is starting from 1 to 26. So if it is 1 and 10, then it's fine, because 10 has the alphabet associated with it, but 0, we don't have anything associated with 0. So we are going to return 0 from here. There is another case. There is another case which says str dot size. What if we are very close to the ending, means if it is -1, all right, and if this is equals to I, so basically we are going to complete the entire string. So this is also a positive scenario where we are completing the entire string. So we are going to return 1 in that case as well. So if it is already greater, which means we have already completed. If it is 0, then we know that we are going to return 0, because we don't have anything associated with 0. And if it is already at the end, we again know that we have completed the entire string. So these are the few base conditions. The base conditions will help us to terminate this recursive call. What we have done is we have taken 1 and 2 situation, and we have taken the rest situation. So far so good, it's good. But as we discussed previously, that we are going to introduce DP perspective as well, because we do not want to compute and recompute the same subproblems, right? So what I'm going to do is I'm going to create a DP. So DP array, which will be a vector int type, and DP, which will have the size str size, and that is going to initialize all with -1. All right, and we are going to pass this DP, and we are going to populate this DP. So we will pass in the argument as well, which is going to be vector int ampersand is, because we are going to change the value. All right, and now wherever we are calling this function, we're gonna pass this d as it is. Sorry, it's dp, not d. And here as well. As I said that we are going to compute, we are going to replace the value of dp. So these are the places where we are calculating it, right? And when we are done with the calculation, we want that particular value to get stored in our dp array. So that is why I'm just adding that dpi assignment. All right. As I said that we do not want to recompute already computed values, so we're going to add here else if dp of I, if it is not equals to -1, then we know that that particular location has been already filled with the valid that has been already calculated in past. So we are not going to do this recursion for it, but rather we are going to return the dp of I from here itself. So this is going to help us to avoid all the recursion for all the problems again and again if we have already calculated in the past. Now this is the part of the DP, and we have solved this problem using recursion. We have optimized it by adding this array DP, but there is another one more point which is yet to get implemented in this particular code, which is this particular line, this particular part, sorry. As the answer can be large, return the answer modulo 10 to the power 9 plus 7. So why do we have to do this modulo 10 to the power 9 plus 7? Just to avoid the overflow of the integer. So here I am going to introduce a long int mod. Mod will be the name of this variable, and it's 1e7, sorry, 1e9 plus 7. So what we are going to do, these are the answers, right, which we are interested in. So all the answers, while saving itself, we are going to do modulo modulo division mod, because this is going to help us to save from overflowing. Now let me just revise this, whatever I have done so far. So what we have done, we have introduced an array, a vector, which is of the size string, and it is initialized all with -1. We are going to call a recursive function which will start from 0, and it has a string and the dp which is initialized with -1. Now what we can do is we'll see that if at any point of time if any string has 1, then it can grow in both the direction, and if it is 2, then it can certainly grow in one direction, but for a combination we need to all be cautious that it should always lie in between 0 till 6. So 20 till 26 will be entertained, and we can grow in both the direction. But if that is not the case, if it is not 1, or if the element is 3, or if the element is 27, then we are just going to grow in one direction, which means that taking each digit indivisibly. And we are doing modulo division with mod, because just to avoid the integer overflow situations. And these are the base condition, which is as important as the recursion call here, because these are the place where the code will terminate. So the termination is number 1 if the size has been completed, or if the size is equals to I. -1 is typically I is at the last position, then we are going to return 1. And if it is if any of the digit or the character, whatever you can say, is 0, then we do not have any alphabet associated with it. So in that case only we are going to return 0. So this is all about this particular problem. So let me compile and see if there is any compilation error or something. So we are supposed to actually return okay, the output is wrong. So let me just debug it. Let me go in this particular situation where it says that else if if my string is 1 and if the string is 2, then we say that it should be greater than 0 and it should be, okay, my bad. It should not be greater, right? It should be less than. So it should not be greater than 6. My bad, my bad. Let me compile. And here you go. We get the correct answer. Now we'll try to submit it. We were discussing that it should be within the range, but weirdly we have written greater than. All right, so this got submitted. I hope you enjoy this video. Thank you very much for watching.